In the last video, I demonstrated how to do a monopoly problem, and I didn't use any calculus. Now, in this video, I want to show you how to incorporate calculus into analysis of a monopoly problem, and I want to show you how using calculus makes it a touch easier. Now, a monopoly just maximizes profit, just like a competitive firm. So what does profit look like? Well, profit's just revenue minus costs. Price times quantities are revenue, and then we have the cost function, and we subtract that off, and it's a function of whatever your quantity is. Now, when you have a monopoly, this price isn't constant, and it in fact varies with Q. So what we can do is we can make this a function of Q, and we'll just call it our inverse demand curve. Now, what do firms do when they maximize profit? They take the derivative with respect to Q and set it equal to 0. Okay, so that's what we did here, is we just took the derivative of this term using the product rule, first times derivative of the second, plus the second times derivative of the first. And then we just took the derivative of this to get our marginal cost. Now we can rearrange some terms here and label some things, and what we'll see is that this is just our marginal revenue equals marginal cost. And this is what we showed from the last video, is the condition that we use to get the quantity. So this is how in general you would do this. You just set up a profit maximization problem, find the first order condition, and solve that first order condition for the profit maximizing quantity. Now, let's take a look at this term here a little bit more closely and see what we can learn. Now, one thing we can do for this marginal revenue term is we can factor the inverse demand function out. And when we factor it out of this term, we have to divide it out because we don't see it, so we have to divide it into the denominator. So now this expression is looking awfully familiar, especially this term here. This term is actually 1 over the elasticity of demand. So this is going to be the condition that the monopolist uses to find its profit maximizing quantity. Now the first thing that this points out is that when we look at this form, this part here is our marginal revenue. And what we'll see is that this 1 plus 1 over epsilon d is going to be a number less than 1 because epsilon d is negative. So this marginal revenue is less than the inverse demand. That was something that we derived graphically in the last video, but mathematically we also see that it is true. Another thing that this points out is that we can actually figure out what range of elasticities would be admissible for a monopolist. So let's go ahead and figure that out from this expression. Now, first things first, we know that our marginal cost, if we just look over here on this graph, our marginal cost is going to be bigger than 0. So that's bigger than 0. That means the left-hand side is bigger than 0. We can take this inequality here and sort of divide out the inverse demand. Because it's a positive number, it doesn't change the direction of the inequality. And the next thing that we can do is we can just isolate this elasticity of demand. Now, if we multiply every term by the elasticity of demand, it's a negative number, so it'll change the direction of the inequality. And then we can just subtract this 1 from both sides. The elasticity of demand must be less than negative 1. In magnitude, it must be bigger than 1. Because it's a negative number, it's going to be a number like negative 1.5. Now what this tells us is that a monopolist must price on the elastic portion of the demand curve. If you see that the elasticity of demand in an industry is inelastic, that is closer to 0 than negative 1, less than 1 in magnitude, then you know that this is not a profit maximizing monopolist. So if we go over to the graph to sort of see where this applies, remember that the quantity is set where marginal revenue equals marginal cost, and the price is set up here. What this means is that this point here must be a point at which the demand curve is elastic. An intuition for why monopolist prices on the elastic portion of the demand curve is to just go through a story and ask, well, what if they were on the inelastic portion of the demand curve? Now, if monopolists were on the inelastic portion of the demand curve, That means that if you raise the price by 1%, the quantity will go down by less than 1%. Now, if you think about what that does to revenue, price goes up by 1%, quantity goes down by less than 1%, revenue will go up because that 1% price increase more than offsets the decline in the quantity. So that's a spot on the demand curve where revenue goes up as the price goes up. But notice that the quantity also goes down, so we get to save on costs as well. So you decrease the quantity and you get a higher revenue and lower costs. A monopoly would never go for that because a monopoly maximizes profit. So intuitively you see why a monopolist doesn't price on the inelastic portion of the demand curve.